rank of the word when the alphabets are arranged as in the form of a dictionary. First, we have taken mother. Next, mirror. What do you find the difference between these two? In mother, you have all the letters different. In mirror, you have the letters repeated. So let us find the rank of this when they are arranged as in the form of a dictionary. First of all, what is the form of the dictionary? Like if you refer to dictionary, what happens? All the arrangements are starting from A. First, all the alphabets that are the words that are starting with A are arranged next B, next C, like that. So if this mother word is arranged as in the form of a dictionary, what should be its rank? Let us see the short form of doing this. See, you have to give the alphabetical numbering to this one. Alphabetical numbering is what? A, B, C, D, E. This is 1. G, H, 2. I, J, K, L, M, N, O. M, N, O. That is 3. 4. P, Q, R, S, T. 5. This is 6. So I have to give the alphabetical numbering to this mother. Now we have to count the number of digits that are less than each digit only to its right side. Only to its right side. Like what? Less than 3, 2, 1. That is, you write 2 here now. Similarly, less than 4, only to its right side. Don't forget, only to its right side. That is, for less than 4, 1, 2. Again 2. Less than 6, 2, 1, 5. There are 3. Less than 2, only 1. Less than 1, none. Less than 5, none. So now, start writing from 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, only from its right hand side. Only from its right hand side. Then, multiply this. Multiply this. Like 0 into 0 factorial, 0. 0 into 1 factorial, 0. 1 into 2 factorial, 2. 3 into 3 factorial, 18. 2 into 4 factorial, 48. Then 2 into 5 factorial, 120 into 2. 120 into 2. That is 240. Now add this to get the number of arrangements before mother. To get the number of arrangements before mother. How many are this? This is 10, 18. That is 1. Next, 2, 6, 4, 10. That is 3. Plus 1 for mother. That is 309 is the rank of the word mother if the alphabets are arranged as in the form of a dictionary. Okay. Similarly, what makes the difference between that and this? If you see mother, all the letters are different. But in this one, 3 R's are there. So let us see how to write the alphabetical numbering for this one. So first, IJK element, that is 1. This is 2. O, 3. Next, 4, 4, 4. Because the repetition of R is there for 3 times. Now, as in the previous case, just write the similar type, that is, count the number of numbers that are less than 2 only to its right side. How many are there? 1. Only 1 is there. But don't forget to write the number of numbers that are repeated. Here the repetition are 3. So divide with that one, 3 factorial. So 1 upon 3 factorial. Less than 1, nothing is there. Nothing is there. Less than 1, nothing is only to its right side. Nothing is there. 0 by 3 factorial. Of course, this becomes 0 only. Next, less than 4, only 1 is there. Including this 4, 3 are repeated, 1 by 3 factorial. Less than 4, again, only to its right side. Only 1 is there, including this 2 factorial. Less than 3, none. Less than 4, none. So, similarly, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Just multiply this. 0 into 0 factorial, 0. This is 0. This is 1. This is 1. This is 0. This is 5 factorial by 3 factorial. That is 5 into 4, 20 remaining. Add this. Add this. Now, what is it? 22 plus 1 for mirror. So, its rank is 23. Like that, you can find out the rank of any word when they are arranged as in the form of a dictionary. This is the method without repetition, and this is with repetition.
थोड़े spotlights.
Good afternoon, every one of you. And continuation to the previous class, we will be taking up the section formula and then the problems related to it, and after that area of the triangle and all. The introductory part let us finish today, and we will then move on to the locus and the change of axis. Okay, so for that purpose, let us now see the section formula. Everyone knows. Please respond, Arun. Do you hear me? And do you see what I am writing here? Just check it out. Yes, Arun. Do you hear me? And just tell me whether you're able to see what I'm writing. This is section formula. Section formula. Respond, please. So in the section formula, whatever the line segment is there, the line segment, this is the line segment. For this line segment, AB, there is another point P lying on the line segment. Let us suppose this is dividing it in the ratio M is to N. This is dividing it in the ratio M is to N. Okay. So you know this formula. I need not have to repeat this, but what the point I like to insist upon, you will be understanding that. See, this is the formula mx2 plus nx1 divided by m plus n, comma, my2 plus ny1 by m plus n. And important point is that this m is to n is positive, then it will be internal division. If m is to n is, this is internal. If this m is to n is negative, then it is external. Don't take them as two formulae, I insist upon. If m is to n is internal, then the ratio is seen to be positive. If m is to n is external, if the point is external, then m is to n is seen to be negative. That's all. In the formula, it is automatically applied, but don't take in your lower classes might be the teachers. They might have given one formula for internal division, another formula for external division. It is not like that, but it is only one formula. Learning the formula like this, is what I'm saying, not correct. It is not correct what I'm saying. So take the formula as one and only one, mx2 plus nx1 by n plus n, and y2 plus n by 1 by n plus. And one extra thing you have to learn with regards to this internal division and external division is that harmonic conjugate points. Of course, in this study material also it is not given, but we have to understand what are the harmonic conjugate points. So, let us understand. This is very simple. Here itself, I will explain you that. That is, if you take a line segment, let me say, if you take a line segment AB, and this line segment AB is divided by a point P in the ratio m is to n, then there exists a point on the line segment, on the same line segment AB, but it divides it in the same ratio but externally divides. That is, you can take it as m is to minus n or minus m is to n, whatever, because minus m by n or m by minus n both are same. Then these 2 points are said to be harmonic conjugate points. These 2 points are said to be harmonic conjugate points. So if you want to write, I'm telling you the definition, please write. Please write. A line segment AB is divided by a point P in the ratio. Good afternoon, Samaigar. Good afternoon. If a line segment AB is divided by a point P in the ratio m is to n, then there exists definitely another point P dash on the same line segment AB, but externally. In the same ratio but externally. That is why we take it as minus. And one more thing, you simply remembering this as positive ratio, negative ratio, that's okay. But why should we take negative here? Why should we take negative here? This is what your understanding will be. That's what the conceptual learning. That is a conceptual learning. While writing positive ratio, you understand, you are writing in this way. You are writing it in this way, AP by PB. What I am saying, AP by PB, please. AP by PB, just to check the direction of measurement. See, it is from A to P. Again, P to B. Both are measured in the same direction. Don't forget. Both are measured in the same direction. Now, if you take external point, what is that happening? Just see that. Here, in this case, what is that happening? You are getting it as AP dash, which is measured in the same direction, divided by P dash B, please. P dash B. So what is it happening here? The direction of measurement is forward in this case and backward in this case, exactly opposite direction. That is why vectorially opposite, and hence you have to make one of the signs negative. So when the point is external, you have to understand that. You have to understand that the ratio is to be taken negative because of the measuring directions are exactly opposite to each other. This is the point generally the faculty never discuss in the class, but it is to be known by you why negative quantity is taken. The direction of measurement differs. This is what you have to understand. So whenever there are 2 points AP and there are 2 points P and P dash with respect to AB, dividing the line segment AB in the ratio m is to n and external point in the ratio m is to minus n, provided m and n are positive. I have to mention that also. Theoretically, m and n are positive. Then these 2 points P and P dash are said to be harmonic conjugate points with respect to AB. Harmonic conjugate points with respect to AB. This is what you have to understand. Okay, now coming to one more point here. there is a question here for you, like whether this point P dash, that is the external point, lies on B side or on A side or both sides. I hope you understand what I'm saying. I hope you understand what I'm saying. Whether the external point lies on B side or A side or any side. Or any side. This is what the question. So let me tell you now how the point lies, on which side the point lies. So let me take a line segment. Let me take a line segment. Similar to the previous case, let me take a line segment. AB. I have taken a line segment A. Now I am taking a point P, which divides AB in the ratio 3:2. Now my question to you, whether this point P, harmonic conjugate point of P, what I mean to say, harmonic conjugate of point P means, what is that you have to understand? P divides it in the ratio 3:2, then it's harmonic conjugate point P dash divides AB in the same ratio, but externally in the ratio you have to understand 3:2 minus 2. My question to you, whether that P dash lies on this side or on this side. This is what my question is. Is this correct? Yes, you are right, Arun. So you followed my lesson in the previous class. So that is why you are answering it correctly. Okay, lower ratio side I explained, but that video somehow due to technical problem I did not upload it. So that is why I am repeating this. See, what is happening here? AP by PB is equal to 3/2. Then what is which one is greater among AP and PB? AP is greater because it is of size 3. If I take the external point P dash this side, what happens? Your AP dash divided by P dash B, if you take, what is that happening? Just see that. AP dash is smaller, P dash B is greater. AP dash is smaller and P dash B is greater, which is against this. Which is against this. If you take P dash this side, what happens? If you take P dash this side, what happens? If you take AP dash, AP dash is greater and P dash B is smaller, and hence the point, external point, lies on B side. So always remember, the external point lies on lower ratio side always. Remember, the external point lies on lower ratio side. This is what I want to discuss. Okay, so here it lies on right side of line segment AB. If it is 2:3, no? Then which side P dash lies? Obviously it lies on A side. It lies on A side. Okay, so this is what you have to understand. So remember, like this, always lies on the lower ratio side. So harmonic conjugate points, you have to see a problem on this one. You have to see a problem on this one. Let me take a problem, and I'm creating the problem here itself. I'm creating the problem here itself, and which is helpful to you, like 2x plus y is equal to 5. I have taken a line I have taken. Of course, in the introduction, I must give you first of all the line, the introduction of the line, and then I have to take this equation. But generally, line equation also you have learned in your lower classes. So what I'm doing, I'm creating 3 points here on this line segment. 3 points here on this line segment. Let me take P here. So how I'm doing this? I'm giving x1, substitute x1 here, y will be 3. Okay, next, I'm taking minus 1 here, x minus 1, y becomes 7. Okay, let me take x2 here, substitute 2 here, y will be 1. So, these are 3 collinear points, understand? These are 3 collinear points. Now, what is my interest here? I want to understand in what ratio this P divides AB. So, I don't know the ratio. Let it be lambda is to 1. It is a method, please. It is a method. Lambda is to 1. Now, apply the section formula. Lambda into minus 1. Minus lambda. This one. Lambda into minus 1. Minus lambda plus 1 into 1. 1 divided by lambda plus 1 is equal to x coordinate is 2. On simplifying this, what is that you get? 2 lambda plus lambda, 3 lambda. 3 lambda is equal to minus 1. Lambda is equal to 3 lambda is equal to minus 1. Lambda is equal to minus 1 by 3. Just simplify and you will understand that. I don't direct step here. What is that? 2 lambda plus 2. This is minus lambda plus 1. Lambda brought this side, 3 lambda. 2 brought that side, minus 1. So lambda is equal to minus 1. So, what is that I was saying? If the ratio you got to be negative, obviously this point P will not be lying in between A and B. So it lies definitely outside what I'm saying. So, and just for the line's sake, I have marked it in between A and B. But according to the ratio, this point P, casually I marked P in between A and B. But it must lie outside AB. And the ratio is minus 1 by 3. Do you imagine? Now, do you understand on which side this P lies, whether on A side or B side? Can you answer, please? Whether it lies, P lies on A side or B side? You answer? According to the ratio we have got, minus 1 by 3, you tell me whether it lies on A side or B side. Can you answer? It always lies on the lower ratio side, I said, isn't it? So it lies always on the lower ratio side. So P must lie here. Your P lies here. So that P is nothing but 2, 1. And what about this then? What about this? It is not P, and I must say, just symbolically if we take, symbolically external point as P dash, then this becomes P dash, the internal point is P. Now you have to find out P according to this ratio, because ratio we have got it to be minus 1:3, and P you will get by applying the ratio 1:3, please. P dash is dividing it externally in the ratio minus 1 by 3, and P divides it in the ratio 1:3. Let us apply the formula 1 into minus 1. Minus 1 plus 3, 2. 2 by 4. It is 1 by 2. 1 into 7, 7. 7 plus 9, 16 by 4. What is it? 1 by 2 comma 4. 1 by 2 comma 4 is the other point which divides it internally, and this point divides it externally. So what is that you have to understand now? P and P dash. This is P dash, please. P and P dash. That I have taken as P dash. This is P only. This P and P dash are said to be what? Harmonic conjugate points. With respect to AB, this is what? The problem related to harmonic conjugate points. Generally, it is neglected. It is neglected in the, of course, in the board level also it is there, but generally the students will not concentrate on this one. So, finally, what are the harmonic conjugate points? If a line segment AB is divided by a point P in the ratio m is to n, then another point P dash divides the line segment AB in the same ratio but externally, or in the ratio m is to minus n, then these 2 points P and P dash are said to be harmonic conjugate points. P and P dash are said to be harmonic conjugate points. These are the harmonic conjugate points, please. These are the harmonic conjugate points with respect to AB. Now, to write this minus 1 by 3 directly, I'll give you a straight formula, direct formula, please. Direct formula, and you can say it a shortcut. See, I'll clear this and I'll give you the, okay, just a moment. What I'm doing, I'm just trying to get the ratio straight without taking all this. Without taking all this. And you remember that the ratio is minus 1 by 2. Don't forget that. Don't forget that. So, whatever the point is there, 2, 1. And the point which divides the line segment is to be taken as xy. Remember. And the line segment is to be taken as x1 y1, x2 y2. x2 y2. Okay, now to get this ratio, the formula you have to understand, you have to write like this: x1 minus x by x minus x2. Simple. What is x1 here? 1 minus x, 2, divided by x here, 2, x2 here, minus 1. So what is the ratio you got straight away? Minus 1 by 3. This is straight formula. Okay, I'll do one thing. I'm giving you straight this as the formula like this. See here. This is, let me say, A, x1, y. Let me say, this is B, x2, y. Let me say, this is point P, xy. If you want the ratio in which P divides AB, the lambda is straight away got like this. You have to proceed with subtraction like this. x1 minus x, again x minus x2. Simple. x1 minus x divided by x minus x2 gives you the ratio. This is a short form, please. Similarly, it can be applied even to y coordinate also. y1 minus y divided by y minus y2. You can make use of that formula, or I am writing this also, or y1 minus y divided by y minus y2. You can make use of this as the short form to find out the ratio. Okay. Now, let's move on to the next part of it. Let's move on to the next part of it, the application of section formula. Now, whenever I need to explain you this, whenever the midpoint of any line segment is needed, then the ratio becomes 1:1, and thereby that formula, in that formula, if you apply, instead of m:(n) 1:1, the midpoint formula is got by x1 plus x2 by 2, y1 plus y2 by 2. Then what is the short form you have to learn here? What is the short form you have to learn here is that short form. If you have a line segment AB and the midpoint is P, then P is equal to A plus B by 2. In the vector form also, you will get the same, A bar plus B bar by 2. And if you are given midpoint and you have to find out the other extremity, that is A and P are given, if you want B, no? If A and P are given, P is said to be midpoint of AB, then how to write B? B simply, you can write it as twice P minus A. Short form of it. Not short form, it is your common sense, you can understand that. So, if I take an example, then you will better understand it. For example, there is a line segment here for which the point A is given to be -3, -1, and B we don't know, and the midpoint M is given to be some 5 - 7. Then how to find B? Very simple, that's what I said. Here I took it as M, no? M as midpoint. M is equal to A plus B by 2. Then B is equal to twice M minus A. B is equal to what? Twice M minus A. What is twice M, please? 2 into 5, 10, minus of -3, comma, 2 into -7, -14, minus of -2. For a better understanding, I am putting it on the paper, but you can straight away, you must be in a position to write that straight, -14 plus 1 -13. So 13 comma -13 is the other extremity you have to understand. 13 comma -13 is the other extremity. So you can, when your one extremity is given, other extremity is not known, midpoint is known, then to find out the other extremity, you can make use of this formula, like twice the middle point minus given point. Twice the middle point minus given point gives you the other extremity. Okay, this can be taken as the short form to find out the other extremity. Okay. Now, this is a straight line formula. A line segment AB is line segment AB is divided by another line AX plus BY plus C equal to 0. Then the ratio is given by minus of AX1 plus B1 plus C by AX2 plus BY2 plus C. Let me explain you. Sahitya Basri, good afternoon. Let me explain you this, how this is derived, this formula. Okay, so let me do that. See, of course, this comes in the topic straight line, but it can be done now itself, no problem. It can be done now itself. Let me explain that. See, there is a line segment. Line segment. AB. And its coordinates are given to be x1, y1, x2, y. Now, this is divided by another line segment ax plus by plus c equal to 0. Now we are interested in which ratio this line segment AB is divided by this line. We don't know that. Let the point of intersection be P. Very simple. Just understand it. I will complete it within no time. This is the ratio. Let us suppose it is dividing it in the ratio lambda is to 1. Now this is lambda, this is 1. Now apply the section formula. What is the section formula, please? Lambda x2 plus x1 by lambda plus 1, lambda y2 plus y1 by lambda plus 1. But understand that this P is lying on AB and as well on the line. That means P is common to both. P is common to both. And hence, let us now get lambda value by substituting in the line segment. By substituting in the line segment. Okay? Let us do that. Let us do that now. See, if you substitute that in the line segment, what is that we get? Do you understand? What is it I'm doing? I'm substituting P here. A into lambda x2 plus x1 divided by lambda plus 1 plus B into lambda y2 plus y1 plus C equal to 0. Kamlesh, commenting means whether you are in a position to see the picture properly or not, and whether you are in a position to understand the concept or not. That's what the comment I asked, Kamlesh. So, if you want to find lambda here, then simply take LCM, and I am writing direct step here because you will understand this easily. A lambda x2, lambda taken common, A x2. B lambda, lambda taken common, by2. After taking LCM, you will get C into lambda plus 1. Taking lambda common, you will get C. And take rest of all the terms to other side. What is this? AX1 is there, BY1 is there, plus C is there. So that is transferred that side and you will get it as minus of AX1 plus BY1 plus C. Then what is lambda here? The formula what we have seen now, minus of AX1 plus BY1 plus C divided by AX2 plus BY2 plus C. So what is that you have to understand? Simple. When 2 points are given A and B, then this point P is the intersection of this line segment with AB. Then our interest is to find out the ratio in which the line segment is divided by the line, in what ratio it is divided. So we don't know that. We have taken this to be lambda is to 1. And thereby we applied the section formula and we have got P as lambda x2 plus x1 by lambda plus 1 and lambda y2 plus y1 to lambda plus 1. But this P is also lying on this line. So we substituted that point P on AB in the line segment, it must satisfy. So we got it to be minus of x1 plus b1 plus c by x2 plus by2 plus c. This is what? The formula to find out the ratio in which a line divides a line segment AB. Let us see now. Let us see. That's what the formula is given. We have seen. Which is the formula? This one is the formula, please. This one is the formula. Just now I derived it. Go to the statement. Straight line x plus by plus z is equal to 0 divides the line join of points x1 by 1 x2 y2 in the ratio minus of x1 plus b1 plus c by x2 plus by2 plus c. Okay. Now, let me explain you this with that by creating a question like this. See, the question is there are 2 points. There are 2 points, please. This is a line. Let me say the line equation as 2x plus y plus 1 equal to 0. And I have taken 2 points here. One point is minus 3 minus 1. And another point is seven minus 2. Now what I am asking you, do you tell me whether these points A and B lie on the same side of the line or opposite sides of the line? That is, what I mean to say, A is lying this side and B also lying this side, or A lies on this side and B lies on this side. What I mean to say, A and B lie on the same side of the line or A and B lie on the opposite side of the line. This is my question to you. Thank you, Somega. My question to you, please. Now, A minus 3 minus 1, B 7 minus 2 are 2 points with respect to the line 2x plus y plus 1 equal to 0. Then, find whether the points A and B lie on the same side of the line or opposite sides of the line. So, I'll explain you first. How to do that, I'll explain you. Simple. I'll explain you like this. See, there is a line like this. Okay? Now, there are 2 points like this. One point is this. Another point is this. Then you tell me whether the line joining these two is dividing the line segment internally or externally. That means you tell me P divides it internally or externally. Reply please. Okay. Somega, you answered it opposite. Okay. Okay, let me check. Now you tell me students please. This is a line. This is a line L equal to 0. Now you tell me if the points A and B are lying on opposite sides of L equal to 0, then you tell me whether this line is intersecting AB internally or externally. Reply please. That's good. Samika replied it is internally. Okay. And now I am making it another way. I am taking 2 points like this now. 2 points like this. This is 1 point. This is 1 point. This is another point. Let me name them. Let me name them. This is A. Okay. Now, let me say this is A, this is B. Now I am joining these two. Now you tell me whether this AB is dividing L equal to 0. Tell me whether AB is dividing L equal to 0. Reply please. Arun, are you there? AB is dividing L equal to 0 directly. No one replied this. Yes, Arun, you are saying yes, sir. Yes, sir means what? What do you mean? You mean to say whether it divides, AB divides L equal to 0 internally or externally? It is not dividing it directly, and hence it divides it externally, please. It divides it externally. This is what you have to understand. So this is the external point now. External point. So if the AB is divided by L equal to 0 externally, then resultant ratio must be negative. If the resultant ratio is negative, then it divides externally and the 2 points lie on the same side. If the ratio is positive, then it divides it internally, then the ratio will be negative. Now let us find out the ratio here. Let us find out the ratio. Yes. What is the ratio formula just now we derived? This is the ratio formula, please. This is the ratio formula. Let me substitute the values here. This is the ratio formula. Okay? Now let us substitute. Two into minus 3, please. Of course, you have to write minus of. I'm writing directly 2 into minus 3, minus 6. And ax1 plus by1, that is minus 1 plus 1. Substitute the point directly in the line equation. And here 7 into 2, 14, 14 minus 2, plus 1. How much is it? This is minus 6 by 13. This is positive. You got the ratio to be positive. That is, this is the case. A and B are lying on opposite sides of the line segment. That's what somebody got answered in the chat before almost 10 minutes ago, 7 minutes ago. He answered it is opposite. Opposite is correct, but I explained it. So if the ratio is got to be positive, then the points lie on opposite sides. If the ratio is got to be negative, then the points lie on the same side of the line segment. This is what you have to understand with regards to the ratio. Okay. Now, this is a straight problem. I don't want to take this because the 2 points are given. 2 points are given. This is 1 point. This is another point. These 2 points are given. Ratio given, and you have to find out the point which divides it in the same ratio. That's straight formula application. Let us leave it. Next, let us see this one now. Without putting your pen on the paper, let us try to count this. The line x plus y is equal to 4 divides the line joining minus 1, 1, 5, 7 in the ratio. So what is to be done here? You have to substitute this point directly in this one. By substituting that point directly in that one, what is that you get? Minus 1 plus 1 minus 4. In the formula, you have minus before it, divided by, substitute this point, 5 plus 7 minus 4. 5 plus 7 minus 4. What is this? 4 by, this is 12 minus 4, 8. Answer is 1 by 2. And I said without putting the pen on the paper, but I have taken, I wrote on the paper. But you can count it. You have to develop that mind calculation always to be successful in the objectives. So how to do that? Substitute this point directly. Take the value. What is it? Minus 1 plus 1, 0 minus 4. So you got minus 4 by substituting this point. And by substituting this point, 5 plus 7, 12 minus 4, 8. So it is minus of minus 4 by 8. It is 1 by 2. So 1:2 internally. 1:2 internally. Like that it is. Now, coming to the next part. That is, if a line is there, let me say this is x-axis. Let me say this is y-axis. Now let me take a point A, x1, y. Let me take another point B, x2, y2. And as I said, this is x-axis. This is y-axis. This is y-axis. This is negative x-axis. This is negative y-axis. This is the horizon. And what is our interest here? Our interest is in which ratio these 2 points are, in which ratio the line segment is divided by the x-axis and y-axis. That is our interest here. What is that? This is the line segment. Now our interest is in which ratio this y-axis is dividing and in which ratio x-axis is dividing. Simple. Very simple. I think you wrote it as minus 6 by 13, Arun. But it is minus of minus 6 by 13, no? Yes, check it out. Okay. The ratio in which AB is divided by x-axis, the ratio in which AB is divided by y-axis. See, on x-axis, in the beginning class, I explained you y coordinate is 0. On x-axis, y coordinate is 0, please. For this one, what I am saying. For this one, y coordinate is 0. And for this one, x coordinate is 0. Okay? X coordinate is 0. Now, let us find out the ratio in which it is dividing AB is divided by x-axis. So let the ratio be some lambda is to 1. Ratio be lambda is to 1. Okay. Let me take the ratio as lambda is to 1. I will name it. This is P, this is Q. Now I am interested in P here. So P formula lambda x1. I am writing only y coordinate because y coordinate is 0 here. Lambda y1 lambda y1 plus 1 y2 is equal to 0. Okay. Just a moment. This is, just a moment. Now apply the formula, please. Apply the formula. What is the formula? Lambda is to 1. What is the formula here? Section formula, lambda x2 plus x1 is equal to 0 for this one. And thereby, you got lambda as minus x1 by x2. So y-axis divides it in the ratio minus x1 by x2 and x-axis divides it in the ratio minus y1 by y2. This is what you have done. X-axis divides in the ratio of y coordinates with negative quantity and y-axis divides it in the ratio of x coordinates ratio with minus. So this is the formula. So what is the conclusion here? What is the conclusion here? If a line segment A and B have the coordinates x1, 1, x2, y2, this line segment AB is divided by x-axis in the ratio minus y1 by y2 and y-axis in the ratio minus x1 by x2. And you will get, don't forget, you will get the same formula even in 3D also. Even in 3D also you will get the same formula please. If it is Z, you will get z-axis extra there. Z-axis divided by this line segment A, x1, y1, z1, b, x2, y2, z2 in the ratio minus z1 by z2. So it is just extension, it is 2D and that is 3D. So Let us now go through the problem. What is the problem? Now, the line joining 2, minus 3, minus 5, 6 is divided by y-axis in the ratio, please. Y-axis in the ratio. Just see that. It is y-axis. These are the points. Now, what is the formula we have learned? What is the formula we have learned? Minus, because it is y-axis, you know. For y-axis, what is the formula we have learned? Minus x1 by x2. So minus x1 means 2 by x2 means minus 5. So the ratio should be 2 by 5. So, which is the answer here? This one is the answer. Two is to 5 is the answer. Now what I am saying, the 2 points are given and it is divided by y-axis in the ratio of minus x1 is to x2. I applied the formula, I got it to be 2 by 5. Now, yes, Samaya, that's right, Andy. That's right. 2 by 5, you answered it. Now, do you tell me in which ratio x-axis divides? I expect the answer from you without putting your pen on the paper. I repeat, the same question, I am converting it like this. The line joining the points 2, minus 3 and minus 5, 6 is divided by x-axis in the ratio. Yes, respond. No, minus y1 is to y2, no? Minus y1 is to y2 means minus of minus 3 by 6. Minus of minus 3 by 6, that is 3 by 6 is 1 by 2. It should be 1 by 2. Samaya, that is not 2 is to 1, it should be 1 is to 2. On x-axis, which coordinate is 0? On x-axis, which coordinate is 0? Y coordinate is 0. So what is the formula? My2 plus ny1 by m plus n must be 0. Common sense. You don't have to take it as a formula. It is a common sense. So what is that you get? My2 is equal to minus ny1. What is that you get? Finally, m by n is equal to minus y1 divided by y2. This is the formula. Yes, sir. Yes, you're right. You wrote 1 by 2. That's correct. Arun, you did not answer that. Minus of minus 3 divided by 6. It is 1 by 2, please. It is 1 by 2. Okay? So, now, some points of a triangle. He said it as some points of a triangle, but I I say them as centers of the triangle. Centers of the triangle. Now what I do, I'll explain it on the board. Which is known to you. The centers of the triangle, the definitions are very much given in your lower classes itself. So, let me explain you that on the board. Just to revise the things. Centers of the triangle. First one is centroid. Generally, centroid is a very well known center of the triangle because you have the formula in your lower classes itself. But particularly in the coordinate geometry, what I say, you must be thorough in the verbal definition. You must be thorough in the verbal definition. If you are not thorough in the verbal definition, that verbal form is always to be converted to the algebraic form. See, generally, the students, they feel coordinate geometry difficult because of this reason. What is the reason? In coordinate geometry, always the question is given in the verbal form. Always the question is given in the verbal form. And that verbal form is to be converted to algebraic. To convert it to algebraic form, that verbal form must be properly understood by you. You understand what I'm saying? That means you must read the entire definition properly and you have to understand it. And after understanding it, you have to apply that conditions or definition, whatever, to the algebraic form, and finally you have to get the result. Why I'm saying all this here? The centroid, the definition of centroid. It is a point of concurrence of medians. Everyone knows that. It is a point of concurrence of medians. Everyone will say that. But immediately if I ask you what is a median, most of the students, they don't answer. Median. What is a median? Median is the line joining any vertex. The line joining any vertex to the midpoint of its opposite side. Let me say that's midpoint as D. Let me say that midpoint as D. Please respond whether the board is clear or not. Please respond. I'm trying to improve the board quality also. I kept two lights, one this side, another that side. And still, because it is lockdown movement, I cannot get an electrician to correct this. I cannot get any other lights also. I cannot purchase them because all the shops are closed. It's lockdown period. So I'll try to improve this still. Okay, but till then, you respond whether the board is clear or not. Please tell me that. Now, what is a median? It is a line joining any vertex to the midpoint of its opposite side, like this. The line joining any vertex to the midpoint of its opposite side. So let me take the coordinates x1, y1, x2, y2, x3, y3. Now I am deriving the centroid. What is a property? What is a property? You have to understand. The centroid, what I said, is the point of concurrence of medians. Point of concurrence of medians. So this is another midpoint. This is another median. And this is another midpoint. This is another median. So how many medians we have got? 3 medians we have got. 3 medians we have got. AB, AD, BE, CF. And the point of concurrence is nothing but the centroid. Point of concurrence is nothing but the centroid. So how to get the formula to the centroid? It's very simple. Everyone knows the median is divided by the centroid in the ratio 2:1 from the vertex side. Don't forget that. From the vertex side. You should not write 2:1 like this. You must always write from vertex side. Here it is 2:1. Here it is 2:1 like that. Now apply the section formula. Apply the section formula, then you will get G is equal to, this is the midpoint of BC, midpoint of BC, x2 plus x3 by 2, comma, y2 plus y3 by 2. This is x3 by 2. Okay, now how to get G here? Apply the section formula, 2 into this plus 1 into that, and thereby you will get the section formula as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Don't forget, centroid is always the average. Centroid is always the average. Average means sum of x coordinates by 3. Sum of y coordinates by 3. Very simple. Average. So always whenever you take the centroid of any polygon, any n-sided polygon, sum of all x coordinates divided by n, sum of all y coordinates divided by n gives you the centroid. So centroid is nothing but the average here. So this one, now if you want to take it as in the short form, it is nothing but a plus b plus c by 3. In the vector form also it is taken like that only, a bar plus b bar plus c bar by 3. Now if you want c, if you want c, the c is nothing but 3g minus a minus b. C is nothing but 3g minus a minus b. That means in some problem it is given like this. I'll take a problem here. Let a be minus 7 minus 5, b is 7 minus 2, and G, centroid G is equal to 5 comma minus 2, then find C of triangle ABC. Then C, you generally, if you are working in the board level, C we will take it as some XY or AB or HK, whatever. Then you will apply the formula and do this. But now, in the short form, you do it like this. 3 times of centroid minus A minus B. 3 times of centroid minus A minus B. C directly. Improve your mind calculation, please. Improve your mind calculation. 3 times of G, 15. I'm writing directly. 3 times of G, that is 3 into 5. I'm writing. Minus of minus 7. Minus 7, comma. 3 into minus 2. Minus of minus 5. Minus of minus 2. This is the third vertex. So 15 plus 40, this is 15. Plus 7 minus 7 getting cancelled, so it is 15. And it is minus 6 plus 5 minus 1 plus 2 minus 1 plus 2. So 15 comma 1 is the third vertex. 15, comma 1 is the third vertex. I hope you understand what I did using this formula. 3g minus a minus 3g minus a minus, like that. You can find out the third vertex of a given triangle when two vertices are given and third vertex, centroid is given and centroid is given. Like that, you can apply. Like that, you can apply the short form of this 3g minus a minus. That's about the centroid, please. That's about the centroid. Now, let us move on to the orthocenter. Now, orthocenter. Generally, what I find in the classes, when I ask the definition of orthocenter to the students, most of the students they say. But what I was saying about the coordinate geometry is that you must be thorough in the definition. Definition means the verbal form of it. Otherwise, you will find difficulty in converting it to algebraic form. So, orthocenter is the point of concurrence of altitudes. Orthocenter is the point of concurrence of altitudes. Again, the word altitude is used here. Then you must know the meaning of altitude. What I mean to say by you must be thorough in the definition means you must be thorough in each and every word. You must know the meaning of each and every word geometrically. You must know the meaning of each and every word geometrically. That's what I mean to say. So here, this is the triangle ABC. Now, what I said, the orthocenter is the point of concurrence of altitudes. What is an altitude? It is a line which is drawn perpendicular from any vertex to its opposite side. Like this. 90 degrees. So, what is altitude? It is a perpendicular drawn from any vertex to its opposite side. Similarly, another perpendicular. Similarly, this is another perpendicular. The point of concurrence of all these three is said to be orthocenter. The point of concurrence of all these three is said to be orthocenter. This is what you have to understand. So previously, for circumcenter, you have the formula very much. What is the formula? A plus B plus C by 3. Very simple. Vertex A plus vertex B plus vertex C by 3. For orthocenter, you don't have any direct formula with the knowledge of the introductory part. With the knowledge of introductory part, you don't have any direct formula. But to find out the orthocenter, you must know the concepts of straight line. You have to apply the concepts of straight line. We'll be knowing that then. But till then, you understand what is orthocenter. What is orthocenter? It is the point of concurrence of what? Altitudes. What is an altitude? It is a line drawn from any vertex to the opposite side. Very simple. It is a line drawn from any vertex to the opposite side perpendicularly. Perpendicular. It is a perpendicular line. We can say like this. What is an altitude? It is a perpendicular line drawn from any vertex to its opposite side. Like that, how many perpendicular lines can be drawn from the vertices to the opposite side? 3. The point of concurrence of these three is nothing but orthocenter. We'll have further more properties of orthocenter in the straight line. Okay. Next, coming to, you have the similarity between orthocenter and circumcenter. I'll show you that similarity. What is that similarity here? See, I'll construct the triangle. In a similar way, I'll construct the triangle here to make you understand the circumcenter. Circumcenter applications are there. More applications are there. What is the definition of circumcenter? It is the point of concurrence of perpendicular bisectors. It is the point of concurrence of perpendicular bisector. What is a perpendicular bisector? Again, what is a perpendicular bisector? I explained in the introductory class by taking a problem. I have taken the locus. 2 points are there. And if a point is equidistant from these 2 points, then how many such points will be there? 1 point here, 1 point here, 1 point here, midpoint also there for these two, equidistant. And similarly, if you collect all such points, that will be the perpendicular bisector of this line segment. Perpendicular bisector of this line segment. That's what it is. In the triangle now, it is a point of concurrence of perpendicular bisector. It is a point of concurrence of altitudes. What is an altitude? It is also the perpendicular passing through the opposite vertex, but here this is the perpendicular passing through the midpoint, please. This is midpoint. For your better understanding, what I am naming it, I am naming it as M1. Wait to say M1 by midpoint 1, midpoint 2, midpoint 3. Okay, now the perpendicular bisector, I said no. The perpendicular bisector is perpendicular to the side and passing through its midpoint, please. And perpendicular bisector is perpendicular to the side and passing through its midpoint. Second perpendicular bisector. This is a perpendicular bisector passing through the midpoint of the third side. And there is a little construction problem because it's a rough diagram. You have to understand that. The third perpendicular bisector. Let me reduce this. This is M1 midpoint. So what is the similarity here? This is perpendicular, this is perpendicular, this is perpendicular to the side. This is also perpendicular, this is also perpendicular, this is also perpendicular. These perpendiculars are passing through the midpoint of the sides and these perpendiculars are passing through the opposite vertex. That's what the difference you have to understand. And the point of concurrence of all these three is said to be circumcenter, please. Point of concurrence of all these three is said to be circumcenter, denoted by S. Now, why the circumcenter is used? Why the circumcenter is used? Because the word itself gives you the meaning of it. See, this S is equidistant from the vertices. SA is equal to SB is equal to SC. SA is equal to SB is equal to SC. And generally, it is denoted by capital R, please. What is the capital R, you know? It is called circumradius. It is called circumradius. Why circumradius, you know? By taking this as the center, and this as the radius, if you draw a circle, you know, that circle passes through all the three vertices. That circle passes through all the three vertices. That is why it is said to be circumcenter. So, we also call it as circumcircle. It is circumscribing the triangle. Circumcircle. The circle which is surrounding the triangle, that is passing through all the three vertices ABC, is said to be the circumcircle. Find the difference here. always in the circumcircle, the vertices are equidistant from the circumcenter. SA is equal to SB is equal to SC. It is denoted by capital. Capital is nothing but circumradius. And like centroid, you don't have direct formula for this also. This circumcenter, if you want to get this circumcenter, then you have to apply the concepts of straight line. So these two, what I'm saying, orthocenter and circumcenter, orthocenter and circumcenter, we will get these two in the straight lines. Using the concepts of straight line, we will find out the orthocenter and circumcenter. Finally, you have the incenter. Incenter is the point of concurrence of incenter is the point of concurrence of internal angular bisectors. Internal angular bisectors. See, with regards to incenter, among all these four centers, what are the four centers? Number one, centroid. Number two, orthocenter. Number three, circumcenter. Number four, incenter. With regards to incenter, there are more properties, and you have good number of previous questions also, because it is nothing but the internal point of concurrence of internal angular bisectors. Okay. What is an internal angular bisector? If this is an angle, let me say this as an internal angle, and this one is the external angle. What I mean to say, the outside angle is external angle. This internal angle is divided by a line, bisected by a line. For example, this angle is 60 degrees, let me say. This angle is 60 degrees. Then a line divides it in the ratio in 30 degrees and 30 degrees. A line divides it into equal parts. The angle is divided by the line into two equal parts, 30 and 30. This is called internal angle. What is external angular bisector? If this is 60, the external angle becomes 360 minus 60, 300. 360 minus 60, 300. Then another line divides it in the ratio of 150, 150. So that is called external angular bisector. So the point of concurrence of such three internal angular bisectors is said to be in center of the triangle. Like this is one angle. There will be one internal angular bisector. This is another angle. There will be one internal angular bisector. This is another angle. There will be another internal angular bisector. These three internal angular bisectors intersect at a point, which is known to be in center. Why it is said to be in center like circumcenter? It is circumcenter and that is in center. Circum means circumscribes the triangle. In center means triangle. Inside it touches all the three sides. It touches all the three sides here. Inside. It takes more time to explain the internal angular bisector's point of concurrence, that in center. It takes more time because you have a good number of properties also. We will continue that in the next session. Namaste.